So welcome back once again, and we still continue with addition reactions, and at this step we need to go deeper into two other reactions that are left. On our previous video, for those who have watched it, we did the first two types of addition reactions, which is halogenation and hydrogenation. But now we're left with the other two, which is hydrohalogenation and hydration. We just want to see how do these reactions take place and what exactly do we need to involve as reactants and as well as products. So for those who are just joining us, make sure that when you we're out, after you're done watching our videos, don't forget to like and subscribe to our videos, and also to leave a comment on how we can make improvements so that at least we can give you the best content of all the time. So let's get into hydrohalogenation. So hydrohalogenation, this is a reaction of alkenes. So the model we have is that these are alkenes when they react with the hydrogen halide. When these two react with hydrogen halide, what you are going to have as the result or as a product is what is called a haloalkane. So a haloalkane is formed when that takes place. Alright, so as we move on, the alkene that we're going to use, let's get, for example, here, let's see if we can get, what is this? This is pentene 1. Let's get pentene 1 as our alkene. So pentene 1 is going to react, in this case, with hydrochloric acid. When pentene 1 reacts with hydrochloric acid, how are we going to get a haloalkane? So before we can continue, at this step, I want you to understand that there is a rule that you need to apply, because in this case, two products are possible. Two products, one which is called a major product, and another which is called a secondary product. Now, how do we get a major product? We apply what is called the Markov-Nikov's rule. This rule states that when a molecule is being added to an alkene, which one is the molecule? The molecule we're referring to in this case is this hydrochloric acid. This is the molecule we're referring to. So the molecule has hydrogen and a chlorine gas, and a chlorine atom in this case. So the hydrogen atom from this molecule, when it's joined to the carbon that has most other hydrogen atoms. What do we mean when we say most other hydrogen atoms? Because the idea of addition reactions is to break the double bond so that this can be saturated. How do we break the double bond? Between these two carbon, there is a double bond. So one hydrogen atom attaches itself here, and the chlorine atom comes to attach itself to this other carbon. So what are we saying? We're saying that when the hydrogen atom from this molecule attaches itself to the carbon, between these two carbon, the carbon with most other hydrogen atoms, that becomes the major product. Let us make our major product. The major product is going to be the one that looks like this. So this hydrogen atom comes here first, hydrogen atom, the chlorine comes on the other one, we have a chlorine atom, then we fill the other spaces with hydrogen atoms. As you can see, this is how we make a major product. So this is our haloalkane, which is made from an alkene plus hydrogen halide. And like I said, we also get a secondary product. What is the secondary product? A secondary product in this case is made when the opposite takes place. When the hydrogen atom from this molecule attaches itself to this carbon with less other atoms, and then chlorine atom attaches itself to the carbon with most other, a secondary atom is formed. Let us get a secondary product. So a secondary product will look like this. So chlorine is going to attach itself to the first one, hydrogen, and then we have this is our secondary product. So at this stage, we have made two products, a major product and a secondary product, all from this alkene. So the alkene that we had, like I said, this is pentene 1 reacting with hydrochloric acid. What we get here is we have two chloropentane, and the secondary product is 1 chloropentane. This is our major product and a secondary product. So that's basically how hydrogenation takes place, because we have a hydrogen atom being added and a halogen being added, hence hydrohalogenation. So let us move on to the next type, which is the last type under addition reactions. The last type is hydration. We want to see how does hydration take place. So hydration also follows the same concept of Markov-Nikov, because it makes two products, a major product and a secondary product. So hydration under addition reaction. So what is this hydration all about? The model. Alkenes, what are they reacting with? Alkenes, in this case in hydration, they are reacting with water, with H2SO4. When they react with water, the result, the product that we are going to get is an alcohol. We will get an alcohol at the end of the day. So how is an alcohol being made from an alkene and a water molecule? At the same time, understand as we go deeper that we have a catalyst here, which is H2SO4. Sulfuric acid in this process is going to act as a catalyst. So let us have an alkene. The alkene that we are going to have in this case, we are going to use, let us use butene. Let us use butene 1. This is butene 1. Butene 1 is going to react with a water molecule. So we shall see a major product and a secondary product being formed when these two react. But how is a major product going to be formed from the reaction of these two? We have by the same rule, Markov-Nikov rule, which says that this is the added molecule is being added to this our alkene. But when it's being added, what happens when they are reacting? We have one hydrogen atom attaches itself to the carbon with the most other, and an OH which is left attaches itself to the carbon with the less other. That's how we make a major product. So let us make our major product from this. We are going to have the major product looking like this: 1, 2, 3, 4. So hydrogen atom comes to the carbon with the most other. Here is the hydrogen atom. When you remove one hydrogen, you are left with HO. But as it migrates from this coming to attach itself here, it migrates as what is called an OH. Then the other spaces, they are going to be filled with hydrogen, as we can see. All right, this is the major product. Here's a secondary product. How is a secondary product going to be formed from this? The secondary product is going to be formed when the opposite takes place. That is when the hydrogen atom attaches itself to the carbon with less other. When the hydrogen comes here and OH comes here. So this is how we are possibly going to get, there's an OH, there's an H. So we have this as our secondary product. This is how we make a secondary product. So in a nutshell, in summary, what are we saying here? We are saying the model for this is that alkenes must react with water. This the catalyst is H2SO4. What we make is an alcohol. So this our butene 1 reacts with water When it reacts with water, we have this major product. As we have seen, major product is going to be butan. This is butanol 2. Butanol 2 is formed, and butanol 1 becomes the secondary product. Here is how we make a major product and a secondary product. So thank you so much for watching our videos, as we are going to continue with some more videos as we shall move on to elimination reactions, cracking, dehydrohalogenation. Watch out for more content, for more videos, as we are going to post them. Thank you so much.